And you have a hard drive on your desktop, usually a SATA drive these days, 7,200 RPM. That's running 7.2K, rotational speed or whatever. Usually you're going to get about 80 IOPS, 80 I/O read-write operations to that drive. That's the most you can get out of a SATA drive. The average user is anywhere between, average about 10 IOPS. You do antivirus scans, you can get to 30 to 40. Sometimes things get a little higher, but basically, you can't type fast enough to stress 80 IOPS in a single drive. So everybody has their own drive. I/O contention very seldom happens. However, we get 100 users for VDI. That's 1,000 IOPS on an average for demand. Well, if you've got 80 IOPS per disk for SATA, you can get 140 of 10K SAS, but 180 of 15K SAS. SSDs, which are popular, you can get a lot more IOPS on the solid state drive than you could out of the spinning drive. So if you had an array with 14 drives, 14 times 80 equals 800,000, somewhere around 1,200 maybe, 14 or 16, something like that. About 1,200 IOPS out of a 16 drive array. You need 1,000. Well, that would be good if it was all the data just strike across with no RAID. RAID takes I/O when it writes. Every time you have a RAID 10 system, when it reads data, it's just a single read because the data is already there and it knows which disk to go and it just pulls the data. When you go to write data to a RAID set, for RAID 10, it's going to write that data twice. It's going to write it primary, it's going to write it imperative. You have RAID 5, it's going to write it 4 times. It's going to write the data, it's going to write the metadata associated with that, and it's going to write the parity bit, and it's going to write the metadata associated with the parity bit so it knows where everything is on that RAID type. Every time you write on a RAID 5, 4 times you have to actually hit that set of disks. RAID 6, that's do it 6 times, you double the parity. So X2, 5, X4, 6, X6 for every write. How much of every average user on a desktop, how many reads and writes? Well, it varies anywhere between 20 reads and 80 writes to 80 reads and 20 writes, depending on what your workload is, what you're doing, or whatever. So 2080 to 8020. Wide variety. But industry averages that we've seen out there, usually 60 for an average user that's just doing regular, just standard office user. Well, let's look back here and we'll say 1,000 IOPS for 100 users. 60-40 read write length means that there's 600 reads plus 400 writes going on. If your RAID set, RAID 10, your actual I/O load on the SAN would be 600 plus 400 times 2, because RAID 10 is double writes. So that's 8, that's 6, that's 1,400 IOPS per second needed to provide 1,000 IOPS on the front end, which you counts. If you're at RAID 5, you'd have 600 plus 400 times 4. 16, that's 22 IOPS. 6 plus 400 times 6. 4, that's 3,000. I'm an engineer, I can't do math. So basically, if you had your RAID type really drives whether you can support those virtual desktops. So say you have a brand new fresh array, 1 terabyte drives, 16 of them, you got 16 terabytes of data available, 16 drives, you want to do 100 users, VDI, no problem. Set it up to RAID 5, you're doing good, you're all set, you got plenty of space, it's protected, and you roll that out, and it's RAID 5, and you need 2,200 IOPS to support that, but your 16 times 80 IOPS on the front end with your RAID and everything, you're only going to get about 1,200 out of the front end of that, out of the back end of that. There's only so many spindles you have, and you bought SATA drives. So what's going to happen when those 100 people try to connect and need 1,000 IOPS? You can only provide 1,200, but the actual, because of the RAID stuff, you need to produce 2,200 to get them 1,000. Things aren't pretty. We try to roll that virtual desktop infrastructure, you get that proof of concept, you send people out, take away their PCs, which they'll all be mad if you're doing these little things anyway, you took something away from them. Give it to them, all of a sudden it's a quarter as fast as what they had before, and half an hour later they're standing outside the door with pitchforks and torches, and it's a mess, it's ugly. So why would anybody ever want to do virtual desktops? It doesn't make sense, you can't get enough spindles. Well, if that same array had some SSD plus a bunch of 10K SAS in some sort of hybrid mix, so that you leveraged the SSD speed at 4,000 IOPS per disk, then the capacity of some SATA drives, and you looked at one of these arrays, and between 7 SSDs and 17 10K SAS drives, you could support about 30,000 IOPS in a single array. You do a lot of PGI sessions on that. This right here is the equalogic hybrid array. 6100, 6110, 1 gig or 10 gig. Hybrid array EXS. Oh, and because it's equalogic, you just plug it into the exact same infrastructure they already have with equalogic. And every single volume you have will leverage this IIO capacity because it automatically